After watching this video lecture, students will be able to calculate gas law problems using both forms of Dalton's law of partial pressures. So that includes just dry gases and when gases are collected over water. So Dalton's law of partial pressure basically says that when you have a mixture of gases inside of the container, the partial pressures of each of those individual gases is going to contribute to the overall total of the pressure inside the container. So this initial equation that we see right here, notice you have P total, so that's the total pressure of the container, is going to equal the sum of the individual gases that are in that container. Now in this case, P1 and P2 represent two different gases, but that could go on to P3 or P4 depending on the number of total gases that are in the container. So if we look at the balloon that we have here, okay, the total pressure inside this balloon is going to equal the sum of the pressure being exerted by the yellow gas, the green gas, okay, and of course the blue gas onto the surface of the container. So all those collisions that are happening onto the surface of the container are going to represent the partial pressures of each of those individual gases. So you would end up with the partial pressure of the green gas plus the partial pressure of the yellow gas plus the partial pressure of the blue gas, and the sum of all of those partial pressures will equal the pressure inside of the balloon. So this is just an example of basically any container. We could look at this from any type of closed off container and apply this particular equation. Now this next equation here, the one that you see down here, notice it has a few different pieces. This is the equation that you're going to use when the gases that you are producing in some sort of chemical reaction or what have you are being collected over water, okay? And so this equation has PATM. This is the barometric or atmospheric pressure, so that can be measured from a barometer. The pressure of the gas is the gas that is actually coming from the chemical reaction, and the partial pressure of your water here, this is some of the gaseous particles of water that come from collecting that gas over water. So we're going to go ahead and look here. So when we're collecting a gas over water, so in this little diagram we have over here, okay, if we have an enclosed container, there's some water here, and we're bubbling up gaseous product from a specific reaction, what's going to happen is that that gas is going to float up to the top. It's going to displace the water that's in the container, and basically we're going to collect those gas particles up at the top of that container. Now what happens though is that as the gaseous particles are bubbling up through and displacing the water, occasionally some of the molecules on the surface of the water get put into their gaseous state. So the gas that you collect over water is never going to be completely dry. There's always going to be a few particles of water that you have to account for. So that's where this equation will come in. You'll know that this is the equation you should use because it'll tell you it's collecting the gas over the water. And you'll be provided either the partial pressure of the water at a specific temperature, or you'll be given a chart to utilize. So we're going to go ahead and look at this problem here. It tells us that we have a collection of gases with partial pressures of 2.21 atm and 3.9 kPa respectively. And they want us to tell them what the total pressure of the container is. Now, there's no mention of water or anything like that, so we know that we're going to just be using the simple basic Dalton's law. Okay, so pressure total equals the sum of the pressures in the containers. Now, if you notice, my pressure 1 and my pressure 2 are not in the same unit, so we need to make them match. In this particular problem, they haven't indicated to us that we need to solve for a specific unit. Okay, so it's kind of up to our discretion to decide which one we want to convert. So I'm going to go ahead and convert my kPa, okay, to atm. So I'm going to go ahead and set this up, okay, and plug it into my calculator, and that's going to give me 0.03849 atm. Okay, and then I'm going to take this pressure value in atm and plug it into our equation. Okay, so we got a 2.21 atm plus 0.03849 atm. Okay, we plug those into our calculator, and that gives us 2.248, okay, as our answer, but we're going to go ahead and write it to the correct sig figs, okay, and we end up with 2.25 atm as the total pressure in our container. we've gone ahead, matched up our units, did our summation, and got our answer in ATM. Now in the problem that we have here, they tell us that hydrogen gas is collected over water at 22 degrees C. Now we need to find the pressure of the dry gas if the barometric pressure is 94.4 kPa. So in this case, they told us the gas was collected over water, so we know that we're going to be using this version of Dalton's law, okay? As you see here, okay? Now, we've been given a couple of pieces of information. First of all, we were given a temperature. We were not told the partial pressure of the water, but that partial pressure of the water is going to depend on the temperature that we're at. So in this particular problem, they've provided us with a pressure chart. Okay, we're going to go ahead and find 22 degrees C and the corresponding pressure in torr. So they gave us P of H2O in torr because they gave us the information for the temperature that the water was at when the gas was collected. Okay, they've also provided us with the barometric pressure. Remember, barometers are used to measure the atmospheric pressure. Okay, so we've been provided with our atmospheric pressure, and that's 94.4 kPa. Okay, and I want you guys to notice here that we are not in the same units, so we need to make the units match. Now, again, it's our prerogative because they haven't specified what units we need to put these in, so you can put your units in whatever value or whatever measurement type you'd like. Okay, so I'm going to go ahead, I'm going to convert my kPa into torr, okay, as follows. Okay, the calculator tells me I'm going to end up with 708.058 torr. Okay, and then those are my digits that are significant. Okay, and then I'm going to subsequently go ahead and plug these values into the equation above. Okay, now I'm wanting to get P gas all by itself. So actually, before I put those data points in, I'm going to go ahead and manipulate. So P gas is going to be equal to P ATM minus P of H2O. Okay, so we plug all those in. So P gas is going to equal 708 minus 19.83. Okay, and we're going to plug that in our calculator, and that's going to give us the following answer in torr. Now, some of you may be asking, how do we get the situation where the atmospheric pressure is equal to the sum of these two gases? And that has to do with an experimental approach where basically we equalize the pressure inside the gas collecting tube with the external pressure, and we do that by inserting the tube into a big container of water and basically putting those values or putting those water levels at the same height. Okay, so this is how you do Dalton's law problems, and this is the approach you're going to take.